You're standing on a rocky coastline. The wind is cold. The waves are crashing below you. A child sits beside a fire clutching a shellfish she collected hours ago, while a few adults stare out toward the horizon. Food has been getting harder to find. The rains haven't come when they should. Animals have stopped appearing where they normally do. Nobody here knows it yet, but if things get much worse, their entire bloodline could disappear forever. And here's the strange part. One day, nearly every human being alive might be descended from people just like them. A tiny group, a fragile group, a group so small that, by modern standards, they shouldn't have survived at all. So how did humanity almost vanish? And more importantly, why didn't it? Most people imagine human history as a steady climb. Small tribes become villages, villages become cities, cities become civilizations, everything gradually gets bigger. But that's not what happened. The reality was far messier. Picture this. Instead of a straight line rising upward, imagine a heartbeat monitor. Human populations grew, then crashed, recovered, then crashed again. Over and over. And strangely enough, the evidence for these ancient disasters isn't hidden in caves or buried under deserts. It's hidden inside you, right now, inside every cell in your body. A few years ago, a team of geneticists sat in front of computer models doing something that sounds impossible. They were trying to estimate how many humans existed hundreds of thousands of years before written history. Not by counting bones, not by studying tools, by studying DNA. At first, this doesn't make much sense. How can your DNA reveal how many people lived nearly 1,000,000 years ago? The answer is surprisingly clever. Every generation passes genetic information to the next. As populations grow and shrink, they leave fingerprints inside the genome. Researchers can follow those fingerprints backward through time. And when they did, they found something unexpected. The lines suddenly narrowed, dramatically, like the neck of an hourglass. Humanity hadn't always been numerous. At certain points, our ancestors may have existed in astonishingly small numbers, which raises an obvious question. What was happening to the world? Now imagine Africa hundreds of thousands of years ago. Not the Africa you know today. A different world entirely. Lakes appear and disappear, grasslands spread, then retreat, forests expand, then collapse. The climate keeps changing the rules. One generation grows up beside rivers. The next watches those rivers dry into dust. No weather forecast exists, no reservoir, no emergency food supply. If the rains fail, survival becomes a daily negotiation. And that's where the story changes. Because climate wasn't just making life difficult, it was reshaping humanity itself. Researchers studying ancient climate records eventually discovered something remarkable. Around 1,000,000 years ago, Earth's ice age cycles began changing. The cold periods became longer, harsher, more unpredictable. Massive ice sheets spread across huge portions of the northern hemisphere. Weather systems shifted, rainfall patterns changed, entire ecosystems moved. For animals, this was challenging. For early humans, it could be catastrophic. Food sources disappeared, water became scarce, populations became isolated. Imagine living in a world where the nearest group of humans might be weeks away. If disease arrives, there's no help. If drought arrives, there's no backup plan. Every child matters. Every successful hunt matters. Every winter matters. Think about that for a second. Humanity wasn't thriving. Humanity was hanging on. Picture a small cave overlooking a valley. Smoke drifts from a fire. A family huddles near the entrance. Outside, the landscape is changing again. The game animals have moved. The water source is shrinking. Nobody inside that cave knows it. But scientists tens of thousands of generations later will discover evidence suggesting their descendants came frighteningly close to extinction. Some recent genetic research proposes that our ancestral population may have dropped to roughly 1,300 breeding individuals, not 1.3 million, not 130,000, around 1,300. The exact number is debated. But here's the important part. The bottleneck appears real. Humanity became very small, and small populations are vulnerable. One bad drought, one disease, one environmental disaster. The story could have ended there. But here's where things get interesting. Humans were becoming incredibly adaptable. Imagine another scene. A rocky shoreline in southern Africa. The inland environment has become difficult. Food is scarce. Many species struggle. But a woman kneels beside a tide pool. She reaches into the water, pulls out shellfish, places them in a basket, simple, yet revolutionary. Researchers later discovered enormous shell middens, ancient piles of discarded shells, that reveal something important. Some human groups learned to treat the coastline like a supermarket. The tides became predictable. Shellfish couldn't run away. Marine food sources helped bridge difficult periods inland. Most people assume human survival came from strength. The evidence points somewhere unexpected. It often came from flexibility. The groups that survived weren't necessarily the strongest. They were the ones willing to try something new. And then came another threat, one that sounded like the end of the world. Picture this: an island in Southeast Asia. The ground begins shaking. Then comes an explosion so enormous that it can be heard thousands of kilometers away. The volcano we now call Toba erupts. Ash rises into the atmosphere. The sky darkens. And for years, scientists believed this event nearly wiped humanity out. The story seemed perfect. A supervolcano erupts. Temperatures fall. Plants die. Animals disappear. Humans nearly go extinct. Except there was one problem. Researchers eventually discovered something strange. The evidence didn't fully agree. In India, archaeologists found stone tools below the volcanic ash. Then they found similar tools above the ash. The people hadn't vanished. They'd survived. Ocean records suggested cooling occurred, but perhaps not enough to create the global catastrophe once imagined. At first, this doesn't make sense. If Toba wasn't the killer everyone expected, then what was? The answer may actually be more frightening. Not one disaster. Hundreds of thousands of years of relentless environmental pressure. No dramatic ending, just endless challenges. Again and again and again. Then something extraordinary happened. A few humans left Africa, not armies, not migrations of millions, just small groups, families, friends, children. A few dozen people here, a few dozen there. Picture yourself among them. You've never seen the lands ahead. You don't know what animals live there. You don't know which plants are edible. You don't know if another winter waits beyond the next hill. And yet you keep moving, which creates another problem. When only a small group starts a new population, they carry only a fraction of humanity's genetic diversity. Scientists call this the founder effect. Think of it like copying only a few chapters from a massive library. The new settlement begins with less information than the original. And that's exactly what genetic studies show today. People whose ancestry traces outside Africa generally possess less genetic diversity than populations that remained within Africa. A memory of small beginnings written directly into our DNA. Now imagine Europe. The weather's brutal. Ice stretches across huge portions of the landscape. Winters last longer than modern people can easily imagine. Yet humans keep moving, keep adapting, keep inventing. They learn migration routes. They make better clothing. They build better shelters. They improve tools. And every innovation buys a little more survival, a little more time, a little more hope. Because extinction rarely arrives all at once. Usually it arrives through accumulated failures. Humans survived through accumulated solutions. But if you look around this ancient world, you'll notice something unsettling. We weren't alone. Neanderthals were here. Denisovans were here. Other human relatives walked these landscapes too. They made tools. They controlled fire. They raised children. They hunted. They survived ice ages. And now they're gone. Think about that. Entire branches of the human family tree vanished. Not because they were monsters, not because they were primitive, but because extinction is real. The fact that we're here today isn't proof survival was guaranteed. It's proof someone succeeded where others didn't. As thousands of years passed, humans developed a secret weapon. Not sharper spears, not bigger muscles. Connections. Picture two distant groups meeting. They exchange tools, stories, ideas, knowledge. A hunting trick discovered in one valley spreads to another. A better way to make clothing travels hundreds of miles. A new food source becomes shared information. This was essentially the prehistoric version of a network, and every connection made humanity more resilient. When one group struggled, another might help. When one region suffered drought, another remained productive. The more connected humans became, the harder we were to erase. But the knife edge never disappeared. It simply changed shape. Thousands of years later, people gathered inside cities instead of caves. The dangers changed too. Disease replaced drought. Pandemics replaced isolation. Eventually, airplanes replaced migration trails. And suddenly, humanity faced risks that moved faster than anything our ancestors had ever encountered. Viruses, nuclear weapons, climate change, engineered biology, artificial intelligence. Different threats, same fundamental question. Can we adapt quickly enough? Because if human history teaches us anything, it's this. Our ancestors didn't survive because they were lucky once. They survived because they kept solving problems. A shoreline became food, a fire became security, a story became knowledge, a stranger became an ally. Again and again, humanity found ways to stretch one more season into another, one generation into the next. And maybe that's the strangest part of all. When geneticists examine our DNA, when archaeologists uncover ancient campsites, when researchers reconstruct vanished climates, they keep finding evidence of how close we came to disappearing. But they also find evidence of something else, evidence that humans are unusually good at refusing to quit. And maybe the real mystery isn't how close we came to extinction. Maybe the real mystery is why a species that spent so much of its history standing on the edge kept finding reasons to take one more step forward. Because somewhere in those tiny groups huddled beside ancient fires, someone looked at a world that seemed determined to erase them and decided to try again tomorrow.